now, I'll take this as my cue. Eccentricity. What is eccentricity? It's a ratio. What's it the ratio between? Okay, it's the ratio between two distances, namely from some point on the locus, right, wherever that is, P, to where? To the focus, and then from P to good. Okay, so we would say PS and PD, right? So the way that we wrote that, rather than saying, where did we start? What was the first conic section that we started looking at? Remember? There's the parabola, right? So for the parabola, what was the eccentricity equal to for such a shape? Equal to 1, okay? And the reason why is because a parabola, by definition, the locus definition is PS equals PD. The distances are the same. The ratio is 1 to 1, okay? So in other words, PS on PD was equal to 1. Okay, now let's cover a bit more recent ground. How did we end up with an ellipse? What did we do? Okay, we adjusted the eccentricity to... Now we tried out a half. Okay. Test. Okay, and what we ended up with was an ellipse. Okay, now that's what we're going to pick up. So what I hope you can find is where you've got some of your diagrams drawn and that kind of thing, we need a bit more language to be able to start to talk about this thing. Okay, now the parabola, the ellipse, there are two more conic sections that we're going to look at, but there are so many questions raised by the ellipse. But what we're going to do is we're sort of going to stop, pause there for a little while, sort of chew on it and see what we can learn, basically. Okay? So don't worry, we'll get to rectangular hyperbola in time. The ellipse is what we're going to focus on for now. Huh, get it? Focus? Anyway, sorry. Alright, now, I've been seriously doing that all day. Like, it's just my brain. Alright, now, go back, find where you've drawn one of your ellipses, and if you can't, in recent book territory, draw yourself a new one. For now, just put its center on the origin. That's pretty awful. Okay, now, let's put some tags on this so we can actually talk about this kind of thing, right? The general form of an ellipse, okay, is very, very similar to the general form. So I'm talking about the equation, the general form of the equation of an ellipse. It's very similar to the general form of the equation of a circle, right? And we noticed that, and I think what we ended up with, correct me if I'm wrong, was that 4, maybe? Was it 3? It was 3. Okay, you're looking at something like this. Okay, and the reason why you put it in this form, rather than having say r squared, for a circle on the right-hand side, is, well, can anyone tell me? I can think of at least 2 reasons. Why is this a more helpful form to have things in? Some murmurs. Okay, maybe I should ask it in a more guided way. What would be the problem with trying to have like a number like r squared over here? What's the issue with an ellipse? Yeah, an ellipse doesn't have a radius, okay, in the way that a circle does, okay? Because it's like, well, this distance and that distance is not all the same, because the locus is defined in a different way, okay? So there's your first problem. The second thing that this is helpful with is, once you want to find the intercepts, it's super easy. Once you put in x equals 0 and y equals 0, it more or less leaps attitude, okay? In fact, once you've got some practice, and some of you might already be at this point, if you wanted to work out the y-intercepts, okay, you'd let x equal 0, okay, and you can see that vanishes, so you're left with y equals plus or minus 2. Yes? Okay, and I can repeat it for my x-intercepts. Okay, so this is nice as a form. Okay. All right, now, being that I've got this kind of information on here, let's try and generalize. So you notice I haven't put anything on here. So instead of 3 and 4, I'm going to call this the general ellipse x squared on a squared plus y squared on b squared equals 1. Okay. Now, this is centered on the origin. We'll look at horizontal vertical shifts afterwards. Think about what these numbers are and what these numbers are and what significance there is here. Where would you expect to find A? Where is it on the diagram? Where's A? What distance or what length gives you A? It's, be careful. It sometimes does refer to focal length, but that's kind of with the parabola, isn't it? Right? A, or rather plus or minus A, refers to your x-intercepts, right? So there ought to be A over here and minus A over here. Did you catch it? Okay. In the same way, you're going to have minus B and B. Okay, now, very briefly at the end of last lesson, we talked a bit about the symmetry that you get with the ellipse. Okay, we talked about how you're going to have not one but two foci, and not one but two directrices. Okay, so being that you've got this kind of symmetry, it helps to be able to talk about the axes of symmetry. Right? So in a circle, all the axes of symmetry are more or less equal. Okay, but here there are a couple of important ones. Okay, so let's look at this one. This one here. Wow, that's a really bad line. Okay, now. That's one of the axes of symmetry. In my diagram, it's the longer one. Okay, and by the way, by convention, this is a bit tricky. A is meant to refer to the larger axis of symmetry. Okay, so that's why I've drawn it out as my wider one. If I were to draw one which was taller, strictly speaking, the A squared should be here. Okay, but you'll pick that up as you start doing questions. Because it's the bigger axis, they call it the major axis. Now, we notice this idea of, a circle has a diameter and it has a radius. Well, it has a major axis, but you can't call it a radius, yeah? So instead, this half distance here, which is the longest, the furthest distance you can get from the center, anywhere on the ellipse, okay? Since it's half of the major axis, they call it the semi-major axis. Okay? Question. What is the length of the semi-major axis? It's just A, isn't it? Okay? Which tells you that the major axis is 2A. It's not rocket science. Okay? Now, likewise, no big prizes for guessing what this length up and down here, I'm kind of running out of space in colors, so I'm going to draw it over here. What this axis in the middle, from minus B to B, what do you think it might be called? The minor axis. Because we're in this class, because we're imaginative. That's right. Minor axis, half of it, semi-minor axis. Okay? And likewise, the semi-minor axis is equal to B. Okay, now we have some language to talk about this thing, right? We want to just basically explore it. What can we learn about this thing? What kinds of mysteries does it have which we can try and dig out? Okay. Now, here's a question I'm going to pose to you. Okay, I'll read it out to you, and then I just want you to listen to it, try and get a sense of what it's actually saying, and then I'll get you to write it down. You can write a short form if you like, whatever captures the essence of the question. Here's my question. We can determine the equation of an ellipse given some of its geometric properties. Okay, pause. Say that again. We can determine the equation of an ellipse, this guy, right, given some of its properties. What properties did we use before to land on this? There were 3 of them. Properties, features, attributes, whatever you want to call them. Okay, so, all right, number 1, we used the eccentricity. So we said half, okay, and then see what happens. But there were 2 other features that defined it. Focus, or we started with one and then you get the other one, okay? And the, okay, good. So we started with these, okay, and that gave us an equation. Okay. So now my question to you is, can we go the other way? What if I gave you an equation? Could you determine what the eccentricity and focus and directrix are? And intuitively, you ought to think, well, probably, if you can go in one direction, usually in maths, you can go the other way. It's not always true, right? When you were doing inverse trig last year, you're probably like, okay, wrapping your head around it, you can go in one direction, but it's not exactly the same the other way. Okay? Here, though, we ought to be able to. Okay? So what don't you do, I'm going to get you to spend 2-3 minutes. Don't use this one. We already know what the facts for that one are. Okay? Pick some different numbers. Pick something that isn't going to be too hard for you. Something like, I don't know, x squared on whatever. Okay? Something like that. That's really standard. Could you try and work out what its eccentricity and focus slash foci, directrix slash directrices are? How would you even go about it? Where would you start? I want you to have a think about it first. See how far you can get on your own steam, and then I'll walk you through how I would do it. Okay? Off you go.